Hi, welcome to my projectwizard.com.
Your requested topic is mining semantically consistent patterns for first-view data. Now we move into the abstract. In real-world applications like information retrieval and data classification, we often confront with the situation the semantic context can be expressed using different views with similar information. It is to obtain a certain semantically consistent pattern (SCP) for first-view data, which embed the complementary information from different views, the great importance of those applications. However, the heterogeneity among cross-view representation brings a significant challenge on mining the semantic consistent pattern. We propose a general framework to describe the SCP for cross-view data. A classical correlation analysis method (CCA) can obtain a low-dimensional embedding of the set of heterogeneous representations from different views in future isomorphic space. In particular, CCA is a classical and generally accepted method for feature extraction in multi-view problems. It has a wide range of applications such as computational biology, financial analysis, and information retrieval, and so on. Specifically, it is aiming to building a feature isomorphic space among different views. A novel isomorphic relevant redundant transformation (IRRT) is used. A novel isomorphic relevant redundant transformation breaks non-constraints to linearly map multiple heterogeneous low-level feature space to dimensional redundant feature isomorphic one. Consequently, the correlated representation from different views are coupled together to capture much more complementary information. Furthermore, to mine the semantic consistency among isomorphic representation in mid-level space, we propose a new correlation-based joint feature learning (CJFI) model to extract a unique high-level semantic subspace sharp across the feature isomorphic data. A new space-ratio-based sharp subspace learning algorithm called correlation-based joint feature learning model. By exploiting the correlation across isomorphic representation, CJFI could extract a unique high-level semantically sharp subspace. In this subspace, the request component will be maintained to a large extent without the redundant and noisy information being remained. The proposed IRRT and CJFI in our framework can be easily extended to multi-view cases where it is flexible that either algorithm combined with other existing algorithms can be applied to solve the cross-view problems. Next is our flow diagram. As we start the process, next process is a multimedia document which contains images and text datasets. Next is a semantic consistent pattern for cross-view data. In this SCP framework, a mid-level redundant feature isomorphic space is a bridge between multiple heterogeneous low-level feature space and a high-level semantically shared subspace. Next process is isomorphic relevant redundant transformation (IRRT). It is a low-rank constraint which linearly maps multiple heterogeneous low-level feature space to mid-level redundant feature isomorphic one. It is to capture complementary information from different views. Next process is canonical correlation analysis (CCA). It is multi-view feature extraction. It is beneficial for retrieval, clustering, and classification. In this, we have a method KCCA, that is kernel CCA, which is for non-linear mapping of data into high-dimensional feature space. KCCA to learn web images and their associated text. Next process is correlation-based joint feature learning (CJFI), which is to extract a unique high-level semantic subspace shared across the feature isomorphic data. Next is the isomorphic representation. The requested component is maintained to large extent, eliminating the redundant and noisy information. Next process is evaluation on TLS, CCA, KCCA, and IRRT. In this, TLS and DCA can process the cross-view data in low dimensional. KCCA to capture much more complementary information. IIRT can map cross-view data. Next process is analysis of IRRT and CJFI. IRRT builds mid-level high-dimensional redundant feature isomorphic space. CJFI achieves better classification performance. Next, cross-view data. Isomorphic space by correlating heterogeneous low-level representation to cross-view data. Next, we stop the process. Now I am going to run the process. This is the first form of semantic consistent pattern for cross-view data. Here I am going to load the data set. So click on the load button. A dialog box will be displayed here. So I am going to select the database here. Selected the data set. Then click on the OK button. So data set will be selected and displayed in text box. So now I am going to load the data set in the text box. So click on this button. The data set will be displayed in the text box here. Then click on the next button. It will move to the next one, that is the data set extraction. In this form, I am going to extract the dataset. First, load the dataset. So, click on the load button. A dialog box will appear. Again, I am going to open the dataset here. Okay, the dataset will be selected and I am going to extract this dataset. So, click on the extract button. The data has been extracted and the message box will be displayed here as record inserted. Okay. Then I am going to view the dataset. So, click on the view button. A dataset will be displayed in the preview here. Then click on the next button. It will move to the next form, that is an image low level feature space. In this I am going to add the number of images. So, click on the open button. So, I am going to select the image. So, I am selected this image. Open. Image will be selected here and will be displayed in the picture box here. So, image name will be displayed in the text box here. So, load. So, I am selected this tiger chameleon. Open. Image path will be displayed here. So, it will be displayed in the text box. So, I am going to calculate the width and height of this image. So, click on the calculate button. The image width and height will be displayed and the message box will be displayed. Click on the OK button. Okay. Then I am going to save this data in the database. So, click on the process button. This everything will be saved in the database. Now, I am going to view the database. So, click on the view button. The database will be displayed in the preview here. So, I saved the animal tiger chameleon and path. The image width will be 425 and the height 340 will be saved in the database. So, the image which I open will be saved in it. So, click on the save button. It will be saved in the list box here. So, again, image chameleon will be saved here. So, click on the next button. It will move to the next page, that is a ethnography image and the text. Here I am going to select one of the image. So, open. So, I selected the tiger chameleon image. Open and selected this image. It will be displayed in the image box. So, the original image will be displayed here. So, I am going to do this now. So, load. I am going to load the text of this image. So, I am selected the image text. So, I am going to select the text page. Open. The selected text will be displayed here. Now, I am going to do the steno image. So, first, before stenogrammy, I am going to save this image as steno images. Save. So, the image will be saved and displayed in the picture box too. So, the path will be displayed here. So, now I am going to open this. Now, stenogram images report will be saved. Then I am going to hide the text into the image. So the text will be hidden into the image box. So now I am going to save this. So first I am going to calculate the width and height of the image. So click on the calculate button. Image and height will be displayed here. Okay. Then I am going to save this data. So click on the save button. It will be saved into the database. Now I am going to view the database. So click on the view button. So the name, that is image, the encoded text, that is decoded. This text will be hidden. Everything will be saved in the database. With 425 330 and image will be saved into the database. Next, move on to the next form. It is a text low level feature space. The text image name and the image with height will be automatically displayed into the text box. Now I am going to load the text. That is the text 8 I am going to select here. Then the selected text name, text type, text size, everything will be displayed in the text boxes here. Now I am going to save this data into the database. So click on the save button. The data has been inserted successfully. Will be showed in the message box. Then click on the OK button. So this will be saved into the database. Next I am going to view this database. So click on the view button. So it will be displayed here. So you can view here. That is text 8 and the text size will be 37 and the image name and image width is 425 and 340 and the selected text, everything will be saved into the database. So move to the next form, isomorphic relevant redundant transformation. In this form I am going to open an image. So tiger summarian, I'm going to open this image. So click open. So the original image will be displayed into the picture box, and the path will be displayed. Image name and the path will be displayed in the text boxes here. Now I'm going to change the image color. So click on this button. Image color will be changed. Now I'm going to click on the image into negative. So click on this button. The image will be negative image will be displayed in the picture box. So I'm going to calculate the different height of the color images. That is negative and the color image. So click on the calculate button. Image height and width will be displayed in the text box here. And click on the OK button. So I'm going to save this data. So save. And now I'm going to view this data. Click on view button. So here tiger summarian 425 width and the height will be 340 will be saved into the database. Now I'm viewing in the data grid view. Let's move to the next part. Is a classification clustering using CCA, which is canonical correlation analysis representation. Here I'm going to select here one of the image and one of the text. If there is a match in this table, that will be displayed into the grid view. So number of images will be displayed here and the number of features. If there is a match in this table, if there is a matches in this key table, it will be displayed in the grid view. So compare. There is a match. So in this grid view, the match status will be displayed in the grid view. So like same all the three. So if there is any match on the width and height, it will be displayed in the grid view here. So let's move to the next form, the canonical correlation analysis. First, I'm going to load the data set. So click on the data set and load. I'm going to select the data set here. Yes, I'm selected the data set here. Open. It will be displayed. The data set will be displayed in the button. So I'm going to select the image, another image. So here the selected image will be displayed here. So I'm going to select here the text will be displayed here. Text will be displayed. I'm going to select the one of the text here. So I'm going to select this text. So the text is the selected text will be displayed in the text box here. If there is a match in the image and the text, that will be displayed in the grid view. So it will be displayed in the grid view. Let's move to the next form. This is a framework for semantic consistent pattern. So in this I'm going to select the image. The image database will be displayed here. I'm going to select text. So the text dataset will be displayed here. I'm going to select the text. I'm selected the text as text 7. If there is a match in text 7 database and the image database, the selected text, the matches isomorphic representation of these two tables will be displayed in the grid view here. So I'm going to click on view isomorphic. The isomorphic cross-view data, cross-view semantically consistent cross-view data will be displayed in the data grid view. So move to the next part is a comparison and performance of graph. Now I'm going to view the graph. In this we have a animal name, animal width and height. So I'm going to click on the view button and graph will be displayed here. That is, blue color will be the animal name, in the and the yellow color will be animal width and red color will be the animal height. And the name of the x-axis will display the images name and the y-axis images value will be displayed here. This is the process.